Alright guys, welcome back to our second part of section 6.7, and we'll be done with chapter 6. Okay. Solving inequalities. Now inequalities with radicals are no different really than solving them with linears. Same rules apply. If you divide or multiply by a negative, you got to flip the sign. And it pretty much goes like normal, with one, not exception, but one additional condition. A square root always has to be positive. The a value has to be positive, or else this is an unreal solution, and we're only dealing right now with real numbers. Okay? So we're going to look at two cases. We'll call it case A, where the square root of a must be greater than or equal to 0. It must be. Okay? Now we'll solve that. Square both sides. 0 squared is still 0. So I know this must be true. A must be greater than or equal to 0. Now, case B. The whole equation has to be true. Okay, it's got to be solved. So we're going to subtract 7 from both sides. We're going to get 5. We're going to square both sides. I messed up there. And a has to be greater than or equal to 25. This is also true. Now, if you look at these two answers, you might think, wait a minute. A's got to be greater than 0. Got it. But this says a has to be greater than 25. Well, then this case is irrelevant. If a is greater than 25, it's always greater than 0. But let me show you another way to think about this, okay? We're going to throw this on a number line. And I'm going to put both our answers of 25 and our answer of 0. Okay? When we had 0, what we knew was that it had to go this direction, right? And a nice little dot there because it's equal to. So that red line represents all of a greater than 0. Well, now I'm going to draw a green representation. Green starts at 25, and it goes off in the same direction. So it's going to be a dot. Whoops, green, we'll make it green. It's going to be a green dot because it equals 25, and it goes off in this direction. So can you tell me where those two answers overlap? Where are they both true? Well, the only spots with both the red and the green are all these numbers greater than 25. So the final answer is a is greater than or equal to 25. Now, if you read your textbook, what they're going to tell you to do is test numbers. They're going to take 0 and 25, and they're going to say, test a number between 0 and 25 and see if it works. If it doesn't work, it's not a part of your answer, and that's a great way to do it. I like doing it this way. But think about it. Take a number, any number between 0 and 25. In fact, one that we could take a square root of. So say 9. 9 falls in here. Well, what's the square root of 9? 3. What's 3 plus 7? 10. Is 10 greater than 12? No. So none of these are part of your answer. But any number bigger than 25 is. So your answer is these. A is greater than or equal to 25. So what I'm going to show you is this method. You're going to find both answers. You're going to graph them on a number line. And the answer is where they both are true. All right. Let's see the next couple and see if we can clear this up a little bit. This must be greater than 0. Or equal to. Remember, it can always equal to. The square root of 0 is 0. I'm going to square both sides. 0 squared is 0. Divide by 2. All right, I get this fact. The value of q must be greater than 0. It must be. Okay, that's part of your answer. Let's do the second part of your answer, which is the entire equation. Let's solve the whole thing. All right, ready? Subtract 3 from both sides. 5 minus 3 is 2. Square it. 2 squared is 4. Divide by 2. Now, because this equation was less than, I get the answer if q is less than 2. So if you think about it, q has to be greater than 0, but it also has to be less than 2. So on the number line, I have my two answers. My answer to my first equation was 0. And I knew that it had to be everything greater than 0. It has to go off this way. All right. My second answer was 2. Now I know that's a solid dot because it's also less than, but it has to be less than 2. So what direction would that line go? Well, that line would go this way forever. You look at your graph. I have to be greater than 0. I have to be less than 2. They both have to be true. Where are they both true? They're both true between 0 and 2. So my answer will be all values of q between 0 and 2. It's very easy to check to make sure we're right. Pick any number less than 0. Pick -1. Well, 2 times -1 is -2. I already can't do it. Out of there. A number between 0 and 2. Well, let's pick 1. All right, 1. 2 times 1 is 2. The square root of 2 is about 1.4. 3 plus 1.4 is about 4.4. Is that less than 5? Yes. Pick a number bigger than 2. Pick 5. 2 times 5 is 10. The square root of 10 is 3 something. It's over 3. So let's say 3.2. 3.2 plus 3 is 6.2. Is 6.2 less than 5? No. So none of the answers bigger than 2 work, and none of the answers less than 0 work. So it's only the numbers where they're both true. Q is greater than 0, and Q is less than 2. And that's how we write it. Q is right between 0 and 2. All right. 2 more to go. Let's make sure we get this idea down. All right. So, step 1. Let's make sure we pick all values where that under the radical is greater than or equal to 0, because it must be. Must be greater than or equal to 0. So I'm going to square both sides. And we're always going to get 0 here. Add 1 to both sides. So now I know this has to be true. X has to be greater than 1. It has to be. Now let's solve the entire equation. All right, whoops, made a mistake there. Let's fix that before we move on. All right, the square root of x minus 1 is greater than or equal to 2. So I'm going to square both these sides. X minus 1, 2 squared is 4. I get this. Whoops, I'm going to add 1 to both sides. Must be getting tired now. X is greater than 5. Well, almost seems like I have two statements that are not contradictory, but they're going the same way. X has to be greater than 1, established, but X has to be greater than 5. So where are they both true? Okay, Here's my 1. Here's my 5. I know these are both solid dots, so let's draw the lines. X is greater than 1, goes off that direction. X is greater than 5, goes off in that direction. Look, they both go that way. So where are both equations true? They're both true when x is greater than or equal to 5. So one sure way to do it, get it right all the time, is find both answers, graph them on a number line, see where they intersect. And then you can just try to make sure. A number less than 1 will not work. 0 will not work. 0 minus 1 is -1. It already can't take the square root of a negative. Say a number in here, like say we try 4. Or we'll try 3. It doesn't really matter. We'll try 3. 3 minus 1 is 2. The square root of 2 is about 1.4. Is 1.4 greater than 2? No, it's not. Any number bigger than 5 should work. Let's try 10. 10 is definitely bigger than 5. 10 minus 1 is 9. The square root of 9 is 3. Is 3 greater than 2? Yes. So it's any number greater than or equal to 5. All right, one more. All right, so do our 2 parts. Remember, this has to be greater than 0. So let's do it. The square root of g plus 4 has to be greater than or equal to 0. I'm going to square both sides. I get that. Subtract 4. Now I know that g has to be greater than -4. It has to be. Now let's solve the entire equation. You got to subtract 9 from both sides. Six minus 9 is -3. Now be careful, remember your rules. If I multiply or divide by a negative, I flip the sign. So I'm going to multiply both sides by -1. So I'm going to get g plus 4, flip the sign, is less than or equal to 3. Okay. Now I'm just going to solve it. I'm going to square. G plus 4. 3 squared is 9. And then subtract 4 from both sides. I get g is less than or equal to 5. So now I have my 2 conditions. G has to be greater than -4, but it has to be less than 5. So if you think about it, if what I said is true, if g has to be greater than 4 and has to be less than 5, it's all the numbers between -4 and 5. All right, let's put it on the graph. So our -4 and our 5. All right, let's graph these lines. So anything g is greater than -4. So it goes this way. All right. G is less than 5, which means that goes this way. So where are they both true? They're both true between those two numbers, between -4 and 5. And if you pick any number in those intervals, it'll tell you. Like, what's a nice number that's right between -4 and 5? Not like it's right in the middle, but it's between them. Yeah, don't pick a hard one. How about 0? Isn't 0 right between these two? All right, what's 0 plus 4? 4. What's the square root of 4? 2. What's 9 minus 2? 7. Is 7 bigger than 6? Yes. So it's all the numbers in here. That's how you do the inequalities. It's like there's 2 different steps to it. It's a little bit more tricky. Sure it is, because you get more to think about. But use your logic, use your skill, follow these steps, and you'll get them right every time. Every time. All right, last problem. Just a little formula work to show you why we do some of these things. So this is a formula for gravity. When you get to calculus, or if you get to physics, you'll use these or even develop these formulas to see how they work. But for now, we're just going to use them. Okay. So we have this formula that time is 1/4 the root of 25 minus the height to describe the motion of a ball. So if I know my time is 1 second, I want to figure out how far that was off the water before I dropped it. So I just solve this equation. Multiply by 4. Now this is isolated. Square both sides. Subtract 25 from both sides. And since negative 9 equals negative h, I know that h equals 9. So it had to be 9 feet off the surface if it took 1 second to fall. So that's just some use for these rational radical equations. So I hope your head's not spinning too much. I hope you're okay. I got some problems to practice. I got the little, exit quiz to take. Once we are done with that, I'm going to give you guys a review, and we're going to have a little quiz on just those few sections. Until then, keep working hard, keep working and doing the best you can do. And if you have any issues, tell me. We'll fix it. All right? So I'll talk to you later.